was telling Eric in true startup fashion, we had this idea about 3 months ago to launch this conference, and everyone said that was crazy and too fast, and then we sold out at 250, and then we sold out at 500, then we sold out at 750, and now we're at about 1,000. So thank you all so much for taking the time and effort to be here. And I think for us shows the deep interest there is in how we can use this technology to solve hard social problems, that there is an intersection of both tech and government. And there is no one, I think, thinking more creatively and innovatively about what's possible at the intersection of these two worlds than you. So we're so grateful for you, Eric, taking your time to be here. Eric, in his tremendous generosity, also offered to take some audience questions, and so we are going to, towards the end of the session, leave some time for folks if they have questions. We'll figure out if we can get the microphones working to do that. We will, in real time, start up this thing. If not, we'll just ask you to yell. But do know that we will leave some time for audience questions as well. All right, we're going to jump right in.
And I should say that we understood the technology capability of Colorado 15 years ago, and I spent a fair amount of time at Boulder to try, and we ultimately set up this incredible development center. So to see the scale here now compared to what we saw 15 years is phenomenal. It's just great.
Yes, well, we're so grateful, obviously, for Google's presence here and for their support in making this really one of the tech epicenters of the country we're excited to be chasing. Let's jump in to all the work and thinking you're doing on AI. Just sort of at the broadest level, what for you are the most exciting frontiers in AI development? What are the things that you think are most compelling to you right now as the options for transformational change?
Well, I think for most people here in the room, the current tools, which can be understood as language to language, right? You know, you ask Gemini or OpenAI or Claude a question, gives you an answer. That's a pretty good start. Those tools are so impressive now, and they're getting better. They're on cranks where the systems bring out a new version about every 18 months. So to me, the question is what happens next? And I think there's roughly 3 things that are happening this year that will presage that. The first is infinite context windows. The context window is your query. With an infinite context window, think of it as short-term memory. You can take the answer, feed it in, ask another question, feed it in, ask another question, feed another, and you can do sort of chain of thought reasoning that way. It's a simple way of going from a language to language question to something which is much deeper. You can have thousands of steps. I want to build a house. What do I have to do? First, you have to consult planning rules. Tell me what the planning rules are. Okay, given those planning rules, what kind of architect do I want? Okay, how do I select the architect? Okay, what kind of a house do I want to buy? And you see how it does it in a series. The context windows can be as big as feeding it 50 books. Read all the books, tell me the answer. It's very, very powerful. Second is what are called agents. And agents can be understood as systems with memory. I don't know about you, but I find it very annoying that the thing doesn't remember the context of my question. Agents basically remember what it's done so far, and then they produce a new result. And the third is what I call text to action. And I don't know about you all who manage programmers, but the programmers that work for me never do what I want. They do whatever they want. So in this case, you tell the computer what you want and it does what you wanted. It actually writes the code. And there's evidence that this, in my lifetime, will probably replace most programmers, which is bad news for programmers, but good news for the rest of you, because programmers are kind of obnoxious and expensive and all that stuff. Speaking as a computer scientist programmer. So those 3, which I think are occurring this year, set up a very interesting set of questions. And I'm just going to assert that those 3 are going to occur. They're going to happen, you're going to use them, they're going to be powerful, you'll like them. And I call this the San Francisco School. And partly because all the people that I've talked to who think this way are in San Francisco. And what they believe is that in the next 2 to 3 turns of the crank, which works out to 3 to 5 years, you'll end up with systems, because of the combination of all of these tools, which are equal to the sum of human intelligence. Now, if that's true, that is a very big deal. Right. So that's what I'm working on.
Very big deal. Say a little bit more about this question of AI agents, obviously. What are the direct impacts you see? What are the changes people should expect to see in everyday life from the new capacity of what you think the agents will be able to do?
Well, think about what do agents do for you every day? Like you have a travel agent, or you have a personal agent, or if you're a musician, you have a music agent, that kind of stuff. So think of them as agents on your behalf. And I think what you're going to see is a large set of agent companies, and those agent companies will compete for your attention to do things. And they'll probably start off as free, typically how they do it. And so instead of having just app stores, you'll have an agent store where you can download or purchase or whatever agents. There's a very open question as to what happens when the agents from different companies start to work together. So corporations work very hard to make sure everything kind of works together and it doesn't break. Now, you can decide whether they break all the time or not, but the important point is that they test it. But how do you test a system of multiple agents from multiple companies without knowing what they can do? And yet, how do you test them? What inputs do you give them? How do you know you've given the right tests? How do you know you're done testing, or this thing's not going to cause a flash crash? So flash crash, of course, is where when you combine everything, it all breaks. And there's evidence mathematically that these systems are unstable. So this is a question that is a deep math problem, but also a philosophical problem. Do you want to organize your systems around those kinds of systems that do important things?
No one is probably more engaged on the frontiers of AI and science than you are in some of your work in thinking and investing. Tell us about what you're most optimistic about and excited about in the world of scientific research and discovery, and what AI can do to help accelerate that.
I've been working on this in the last month, and I'm sort of in awe of the progress. Partly this is because this next generation is so much smarter than I was, and frankly some of you as well. They're just so brilliant at applying these tools. And I wonder, was I that smart? You know, way back when? I don't know, but I didn't have those tools. So you watch the way in which they apply these things, and the gains are enormous. We were talking earlier about a company that I work with, which instead of using quantum computation, it's built a quantum simulator using GPUs. And that can simulate essentially quantum effects in material science, drug discovery, chemistry, and so forth. That will yield both a good business, but also much longer living drugs. There are so many examples where AI allows you to very, very quickly accelerate and solve a problem. Another example. In chemistry, they understand the math of how the chemistry works, but quantum chromodynamics and things which I don't understand at all mean that they're not computable. In other words, the physicists and mathematicians were brilliant. They figured all this out. They all have names for their algorithms, but the computers aren't fast enough. They won't be fast enough to do it. Another example would be clouds. I did not understand in my climate work how important clouds were, but most importantly, I did not understand that there's not a good model for cloud simulation. There's something called Navier-Stokes equations. The engineers in the room know what I'm talking about. The Navier-Stokes equations around clouds are not computable in our lifetimes because of the math problems. So I funded a group that built a simulator that used AI to approximate the behavior of clouds with respect to climate change. Does that matter? Yes, it matters a lot because it allowed them to solve another problem. In physics, which is impossible to understand in my view, they use a thing called diffusion models. What physicists appear to me to be doing is they look at something and they try to figure how did it get there. And what a diffusion model does is you take something that exists and you add noise and work backward, and then you run the algorithm forward and you discover the underlying structure. This breakthrough has changed physics. I can go on. But in every field of science, we're going to see a Cambrian explosion because of the application of these things. And one of the interesting things about science is in language, we have largely run out of language. So these training models we sort of crawled all of the words that exist in all the languages. Now, there are probably some places where we can get more words, but we've sort of seen the breadth of human communication, or at least written communication. In science, we already ran out of the training data. So the scientists are busy building systems to generate training data. And so my favorite example is that I was in a lab at Google, and they were working on a strange problem. They were trying to understand whether mice could be detected breathing. Because apparently mice, when they sleep, it's very hard to see if they're breathing. Okay, it's an important technical problem in the mouse community. And so I figured what you would do is you take pictures of the mouse, and then you have the computer detect whether they were breathing. And they said, no, that doesn't work at all. They took a model, a physics model of a mouse, the bones and so forth and so on, and they made simulated mice and had them breathing, and they generated the training data, and they came up with the model that predicted whether they were sleeping or not. Now, I know this is an issue of great interest to everyone here in the room, but I can assure you the 3 scientists that invented this were beyond proud of themselves. So that's a replicable strategy across all of science. Now, why does science matter? Look around you. Every single thing that's around you, including your clothes, everything digital, the building, is all based on science. And by the way, how do economics grow? They don't occur just because of trading. They occur because of productivity increases. And productivity increases come from entrepreneurs and innovation, and the predecessor of those is the science that allows you to understand it. Better materials, right? I can go on.
In that vein, AlphaFold made big headlines recently with their significant advances in solving the protein folding problem. Can you talk a little bit about why you're excited about that, what implications that has for people's experience of availability of public health services? And
a little bit of background about proteins is that 20 years ago, basically, the human genome was discovered. There were lots of awards. A whole bunch of groups, including the Broad Institute, which I'm the chairman of, were founded in essentially around genetics and genetic diseases. There is now a field generally known as proteomics, which is the interaction with proteins. And proteomics is much more complicated, and just as that extra level of complexity occurs, much more powerful computers and algorithms have come to help. And understanding the behavior of proteins is key to kind of everything, because proteins are how the system actually gets essentially driven. The presence of a protein means something, the absence of a protein means something else. The protein folding problem is that it's a chemical structure where the protein folds in a particular way, and modeling that and understanding it is very, very, very hard. And using a set of AI techniques, generally known as reinforcement learning, DeepMind, after a couple of years, and this was after they won the game of Go, by the way, figured out a way to essentially automatically discover the proteins, best way to describe it, from the enzyme description that they were given, and show the folding. And in a competition between DeepMind, I was obviously part of Google, and I was chairman, and a group in University of Washington, which is also very smart. That competition, I think, really helped everybody. And Google and DeepMind ultimately released the maps of the proteins of roughly 200 million proteins. This is a major scientific leap, because every single biology group that I talk to, every biologist is now using this, and essentially to understand the underlying behavior of the system. And why does that matter to us? We're made out of this. This is how drugs work. This is how nutrition works. This is how our lifespan works. By the way, this is how aging works, if you're worried about that. There are all these startups that are using basically various techniques involving anti-aging drugs. They're all based on these technologies. It's very profound.
From the very small issue of mice sleeping patterns to maybe the largest issue the world is facing, climate. Tell us about what you're excited about as major breakthrough opportunities for AI in the fight against climate change.
Well, the most obvious solution to climate is fusion. And for the last 30 years, the standard saying about fusion is that fusion is always 30 years away. And so, and all the fusion people agree, by the way. And there are 8 or 9 startups. I'm the chairman of one of them. They're different technological approaches. One is called Tokamak, another one is called Pulse Fusion, there's a few others. And the basic idea is that you get an enormous amount of energy into the equivalent of a plasma, and that plasma is so hot that it causes the atoms to actually fuse. And when the fusion occurs, it uses something called deuterium tritium, and the structure of the extra, I'll get the physics wrong, but the extra electron gets released as energy, and that extra release of energy is enough to power the whole thing continuously. So it's like having a mini sun. We need fusion in some way by 2040, 2045, where we've really cooked the Earth. The other things that you can do, are a lot of them have to do with material science, lighter weight materials, less carbon in their production, and so forth. And then the final and most obvious one is distribution. When you study the distribution of electricity, there's plenty of solar, plenty of wind, plenty of places to put batteries, and the people are elsewhere. And getting the distribution networks, which can be automated, is a problem. The typical time to get a power line approved is about 18 years in America. That's called not at war against climate change. Right? I'm sure we could do it in fewer than 18 years. Right? These are usually pretty straightforward problems. They're just math and chemistry. I think that if you look today, new solar and new wind is cheaper than, obviously coal. It's also cheaper than new natural gas. So there's every reason to think that the correct strategy is long-term fusion, which is another 6 to 12 years is my own estimate. We'll see if that's right or not. And then the intermediate strategy is a combination of natural gas as a bridge fuel, as well as solar and wind, and fix the distribution grid. Every single one of the things I described is enabled by the physics and math and chemistry that I was describing.
Yeah, really, really helpful.
I'm gonna give you a super example. Why does your car weigh so much? Have you ever tried to lift your car? Right? One person did an analysis and said they could make the car 10 times lighter with just the same amount of crash resistance. And lighter, by the way, means it's much more fun to drive because it accelerates quicker. And I said, why don't we do that? Well, because we haven't decided to do it. But we can do this with enough focus on the materials, the structure, the tensile materials, and so forth. Why am I focusing on 10 times lighter cars? Because it requires so much less power to drive it.
Other areas of exploration, as we think about what's possible in AI, places where maybe just be scratching the surface. I know you've thought about space, genomics, other places where there could be real breakthrough opportunities here. What excites you about what's possible in those fields?
Well, in genomics, so the underlying AI algorithm that everybody's excited is called, it's essentially called the transformer architecture. And GPT stands for, the T stands for transformer architecture. And you can think of it as predicting the next word. So when you use one of the services, I of course use Gemini, you're welcome to use the others. What it's doing is in real time, it's saying, what's the next word, what's the next word? And it produces this extraordinary prose that's so much better than I can write. Well, the same technique can be used to predict genetic sequence, right? So in that sense, we're likely to end up with very novel and very powerful synthetic, genetically designed things. We are able to do it. There are obviously security issues there. But it looks to me like that will allow for another number of very, very powerful synthetic solutions to medical problems of one kind or another. There's a good, in one of my books, we talk about a drug that was invented at MIT. And they took a whole bunch of synthetic biologists and a whole bunch of computer scientists. And the synthetic biologists set out to look for a drug that was a new class of NSAIDs, basically the aspirin kind of things, painkillers. And so they had one group generate an enormous number of combinations of these drugs. And then they used another model, a separate system, to winnow it down to 10 candidates, which both had promise, but were also very different from the existing ones. And the reason they wanted very different ones is that we're all developing immunity to these drugs biologically over time. and it looks like, the drug is called Halcyon, it looks like it's going to work. That would be an example where eventually, after it passes all the trials, hopefully, that you will end up having something besides Tylenol and Advil and so forth to take in a pain situation.
Transformational. Two more questions, and I'm going to open it up to folks that may have questions as we get the infrastructure built to do that. Let's talk about some of the potential risks that we're being prepared to manage. What potential risks specifically do you see with the growing influence of AI in science, and what boundaries should we set and what boundaries should we not set around those questions?
I'm very worried about the misapplication of AI in war, automatic weapons. I'm very concerned about what we call essentially self-recursive behavior. So the system begins to learn on its own, in which case we lose control over what it's doing. And my standard line on this is pretty simple. When the system is beginning to learn on its own and you don't know what it's doing, do you know what we should do? Unplug it, okay? It takes power, there is a switch, just unplug it and call the boss or call the government or like, holy crap. You know? Because when these systems start doing things that we as humans don't understand, that's a danger zone. In science, I'm not so worried about it because there's so many existing policies around the limits of science, scientific review boards, health review boards, and so forth and so on.
You prefigured the next one, which is the other place where folks will have real concerns is national security and potentially what happens with rogue nations or rogue organizations that can get their hands on AI that can be dangerous or threaten America's national security or others. So what do you see as the role here of the right way for us to police them?
Well, let me give you a thought experiment. How would you feel if one of these computers that I'm talking about in a few years figured out a way to get access to weapons? Like, clearly that's not okay. What's really happening is that these technologies are being used to enable robotic war. And you see this in Ukraine and Russia, and I worked a lot on this problem, so I know the specifics. And because of the invasion from Russia, which Ukraine was largely unprepared for, they were forced into a situation where they became startup wartime nation. There are now something like 600 drone companies, and all sorts of variants. And all of these drones can be understood as the person is sitting somewhere and they're not in the drone, and the drone is doing the damage or defending on the other side. So as an example, I was in Kyiv, and I'm in an office building, and the soldier, I guess the equivalent of the Air Force, in uniform is sitting in front of a PC, drinking coffee, running the drone, right, into the other side. That's the future of war. So the future of war is automated, separating the human from where the vehicle is, if you will. And this has a lot of implications. The militaries are generally resistant to change, don't get it, very much patronage driven, and this is true of every military, or culturally driven. They're not driven by innovation. I worked for the Secretary of Defense for 7 years and did a whole bunch of innovation work. It's very difficult to change the bureaucracy, the procurement. It's all well documented. We can talk about it at length. But I think Ukraine shows that in a desperate situation, the innovation can come out and it will change history, in my view. Now, there are all sorts of issues. My favorite example is at some point, these drones, which are today run by these little companies, will be able to talk to each other. Well, does that mean that that person that I was describing can command them all? Okay, probably. Now, subject to communications. We'll see, it's not happened yet. And so now you've got a single person with a huge air force, and the computers are making all the decisions. Okay, how do you feel about that? Kind of so-so. So now imagine that you have a defensive system which automatically sends up the drones to do the attack, and you have no time, the human can't intervene, it has to be by automatic. It's an automatic weapon system. And that's, to me, the line where you really have to think about. Because what are they really going to do? Because you don't fully control these things.
And how do you have a human decision maker in between that reaction?
And there's a well-established principle in the U.S. military called human in the loop. The current preferred term is called essentially under effective human control. I want our military and our national security under effective human control, under people who can be held responsible if they screw up, and who are praised if they do the right thing. And we do not want to change that rule, in my opinion.
Yeah, great thought. Okay, we are going to open up to some questions. Mary is the magic woman with the microphone, so she will find you and offer it to you.
I am really looking forward to questions about the sewers and the schools and all the things you're working on here in Denver.
We're going to have you solve all of them for us. I'm going to do a speed round.
Okay, so slight technicality. We actually cannot move. Keegan and I both have microphones because of this last minute audible. So if you have a question, please come to us. And I think we had one right here to start.
So you might queue up behind Keegan or Mary. We probably will get to maybe 4 or 5, just so people manage expectations. We're ready.
Hi, Eric. It's a pleasure hearing from you. You're such an inspiration, and of course, Mayor Johnston, you as well. My question, as someone, a machine learning engineer in predicting risk events around the world, my question is, how do you foresee the uneven distribution of computing power and access to large data sets across different regions, across different companies, different demographics, impacting the deployment and how the availability of AI technologies across the world?
Thank you. It's a very good question. I want to give you an example of what's happening. In Europe, we have a number of very important startups, all of which I've tried to fund. They do almost all their training outside of Europe because the electricity costs in Europe are too high. They often do it in the US. In the Arab world, you have countries like Saudi, UAE, Qatar, who are largely American partners in various ways. We're building very large data centers to try to take over some of that training. So you want to think about training and access to computers as a global resource, not necessarily a national release, as long as you're not doing national security. So what I think about this, I don't think of it as a hardware problem. I think of it as a people problem. Do you have enough universities in your country producing people who can take advantage of these tools? I will tell you that China has it and the US has it, right? I'm sure of that. How many others? There's 197 countries. What happens with the country that's kind of poorly run, sort of modestly corrupt, people are doing the best they can, the university's not very strong? It's not obvious to me that they're going to participate in this revolution in an economically powerful way. They may get the benefit of an AI doctor or an AI teacher, and their education level may improve, but the economics will favor the relatively large countries that have very strong educational systems, a culture of entrepreneurship, and the ability to use these things. Don't focus on where the computers are, focus where the people are.
Good question. Yes, Keegan. Yeah, if everyone can keep about 30 seconds or under, that'd be great.
Thank you, Mayor, and thank you, Mr. Schmidt. Thank you for taking questions. Thank you, Den AI and Denver Startup Week for talking about the social impact that AI can have. I am January's advisory group, and I show businesses how to make money off of the gaps in their racial equity, social equity, in their algorithms and their lean processes. As I see AI being built in by these larger, say, Salesforce, global platforms, and I see equity or racial equity, the discussion dying off, I still see a major gap in client base and market base for these businesses who are not paying attention to racial equity, social equity while building in AI. Given that DEI is being, say, taken a step back this year,
Just ready to get to a question real quick, so I want to make sure if you can get to the question, I'd love to hear it.
What direction would you give for businesses or startups like myself who are building equity into AI while equity is under attack?
Thank you so much.
The argument in favor of equity is actually pretty straightforward. You have a better business if it's more diverse. More women, more minorities, different religions, different culture, different biases. You just get a better business outcome. I know this to be true, and I know you believe it as well. The problem you have is that tech companies broadly are focused on efficiency over anything else. So the problem is that it's often more efficient to serve the old white guy, right, rather than to work on getting the other people up to the same, speaking as an old white guy, getting everyone else to the same level, and that's the conflict. I think you can do it in culture, and I think you can do it in regulation, but it's an inherent disconnect between economic goals and social goals.
Thank you so much. Next question.
Hey, Eric, Killer Socks. My question is a bit more personal. When you reflect on your life prior to joining Google, what would you say are the 2 or 3 sort of most important or impactful habits, events, circumstances of luck maybe, that allowed you to realize the success that you did at Google and beyond?
I worked from an office 5 days a week.
We support that.
And in that office, I didn't understand at the time, because I was too young, I had mentors, right? In every situation, I had people who kind of said, Eric, that's very clever, and you're completely wrong, right? And that occurs in the informal interaction. It doesn't occur when you're sitting at home, doing whatever you're doing. So ultimately, human activity at the scale I'm talking about requires a lot of people. And you have to learn how to work with them, especially people you don't personally agree with, but who are very smart. And you have to basically organize around common goals. I was very, very fortunate that I was mentored very young. And I think the best thing that we can do, I'll just summarize by saying, is when you look around, the future of our country is in all of those teenagers that you haven't talked to recently because they don't want to talk to you, right? Go talk to them, get them programmed, get them excited about the visions that and she and others are talking about. Get them programmed early. That's the best investment you can make, and I know, Mayor, you agree with that. It's human talent.
Yeah, great, thank you so much for that question. Yes?
Thank you, Mayor and Mr. Smith. So you described, Mr. Smith, the challenges with AI, in particular, the lack of transparency and visibility to what's going on. And my team, we look at it similar to the situation that the world was in before we had the microscope, before we understood that atoms and molecules exist. People applied leeches, they bled people, they did some pretty awful things in hindsight. So what do you think about the idea that what is missing is a meaning representation system, some way to understand what is going on inside of these systems, and what would it mean to be able to have that visibility and control?
So the question you're asking, which is again very good, is an explainability question. Can you explain how you came up with this answer? It's a question teachers ask their students all day. The computers can't explain it. This is why the copyright problem is so important, because it can't explain where it got that song, although it's obvious to you and me that it stole it from, Eagles or whatever it is. But it can't explain that to you. So I think that problem, the consensus in my industry, that problem will be solved with new algorithms and new ways of understanding which nodes are delivering it. So I think we can be optimistic that we'll get there.
A couple more.
Mine's pretty simplistic. So you said something that actually reminded me of War Games, if you remember the 80s movie.
Yes.
And I was at an AI summit where one of the speakers said that the movie Her was actually a documentary. So I'm wondering what kind of cultural touchstones that you think actually capture what the future looks like.
What's interesting about the movie Her is that it was so early, everybody already forgot it. But it got the threat correct. And you'll remember that the computer essentially takes over everything, and then the end of the movie, without spoiling it too much, is the computer decides to stop playing with you. Right? But that's a good example where you can see, there's another movie, his name is escaping me at the moment, where people live in a reality world. And one of the concerns I have about society, which will probably not be in my lifetime, but let's imagine it. So you're retired, you're tired of your family, you're tired of the dog, whatever. You get up in the morning, you have breakfast, and you put your headsets on, and you stay in it until lunchtime, you take them off. And by the way, during that headset, you are what you were 50 years ago. Younger, more handsome, more beautiful, smarter, richer, whatever it is. And you live a virtual life that is more interesting than your real life. And then, of course, after lunch, you put the headset back on, and then at dinner, you do the same thing, and then after dinner, you put the headset back on. And Ready Player One. Yeah, Ready Player One. Thank you. Yes, you're the right generation. It's a very good movie. And of course, they're all combat movies at the end of the day, but that isn't the point. So I worry about the disconnect between the real life that we as humans experience and the online life. Because the systems that I'm talking about are designed for addiction. In that sense, collectively, we are trying to get your serotonin level up, right? And that's why they're so quick. And the impact on that in terms of long-term thinking and reading and contemplation is unknown. And it's a massive experiment on humanity.
Great question. All right, last public question here. Yes.
Hello, thank you. I'm a fourth-year computer science student at the University of Denver, and I'm